Cool, looks like we're on here. Hey everybody. So I today I'm gonna go over some different stuff. I'm Ian. I'm going to basically do some C++ coding. So just a disclaimer: I have not coded in C++ in about 16 years. So I'm gonna be learning a lot of new stuff today, so bear with me because I'm going to be going very slow. If you're interested, I hope you enjoy learning experience and with me as I work through creating basically coroutine support around the co-await and co-return keywords in C++. They're relatively new in, I guess, C++ version 20. So let's go ahead and let's dig into it and see how it goes. I'm going to put my glasses on here for the screen brightness. Okay. Alright, let's switch over here. Let's get to our project. Cool. Alright, I've changed things up where I've got a window. I'm going to use AI just to kind of walk me through this process because I'm so new to coroutines. And basically I'm going to be creating it from scratch. So I'm going to leave this off to the side. And that way you can just kind of focus on basically just watching the process. Feel free to ask questions if you're interested. Okay, so let's see here. First of all, I don't see my project files. So it looks like IntelliJ is kind of ignoring my file structure. But I can see it if I go up here, go to project files, and then go to, yeah, anyways, if I click on this tab, up this drop down, select project files. Include. Okay, so what we're going to do is create an event loop, and we're just going to add a bunch of imports. Start out with the basically just the imports of the various things we're going to need for this. So starting out, we'll need, first of all, it's a header file. So this is our header file. We're going to do, I'm going to go, oops. All projects. Allow editing until ID restarts. Yeah, I don't know what that's about. Okay, right now it's not, my project's not set up, so I might have to do that here in a second. But for now, let's just go ahead and start typing and coding. Okay, first of all, I'm going to go with pragma once for now. So this is basically just, keep from there's a whole thing around basically header files, and you got to do this so that, from my understanding, in essence what happens is you want to basically, the compiler will try to include the header multiple times wherever it's referenced, and pragma once is basically telling it, hey, you only need to compile and this only needs to be included one time, and once it's included, you don't have to, if you see it again, you don't have to keep including it for every file that references it. That's my layman's understanding, because I'm not a C++, again, disclaimer, I'm not a C++, I'm not the best at C++, haven't done it in a long time either. So I'm going to use pragma once. It's simple. It should work using, depending on which compilers you're using. But in general, there is, I think, generally good support for pragma once. I'm going to go with that for now, till it causes me an issue, and I'll go back and update that. Okay, so let's go ahead and start with our first import. pound include, and then we're going to do sys epoll.h. And this gives us access to Linux's, and I actually just learned about this morning. This will give us access to, in essence, Linux's built-in I/O like notification system for basically monitoring file descriptors, which are kind of like handles in my mind on files, and basically buffers or readers, and so they have, I guess they have some kind of event system where when some file descriptor is done or in the process of reading, when it completes, it basically gives you the ability to monitor that notification, because this notification system is built into the Linux, I believe, into the Linux operating system. So we're going to need that for coroutines, because coroutines depend on knowing when something is complete. When it's done, it needs to get notified, so it can update that coroutine to basically it's finished. All right, next include, I don't want to belabor the points too much. Okay, so this is basically, this is just C++'s coroutine. I guess this is C++'s basic coroutine library or support. If I can type with my fingers. Okay. I guess this would be used for callbacks. I think Chrono has been around for a while. It's basically for timer support in C++. These are all built-in C++ libraries or base functionality built. Yeah, it's basically their stand. I think it's in the. I don't know if it's in the standard namespace or in the. It's just a built into C++. Libraries built into C++. They come with the base functionality and support of C++. Let's see, the next one is going to be Q. Okay, this one I don't understand, but according to AI, this is the ready queue plus timer heap. I'm not familiar with the queue import. Okay, vector, that's just what in essence is basically C++ arrays, or at least a slightly more modern variety of their array, with some basic support for like kind of like adding things to it, removing things to it. Let's see, let's go, okay, unordered map. Some of this should be self-explanatory, so hopefully I'm not boring you. Let's see here. All right. Okay, next one. We want to bring in C standard int. Did I type that correctly? Something's wrong here. Or is it just doesn't like the word? Typo. Okay, I'm not going to worry about that for now. Okay, let's see here. Alright, so next we're going to create an event type enum, and we'll see kind of how that gets used. An enum is just a basic enumerator or enumeration. So we're going to do an enum class event type uint 32. Okay, so it's an enum based on integers. Unsigned integer, 32-bit. Did I spell this right? No, yeah, that's correct. Okay. All right, cool. Let's go to our first enum is going to be none, 0. Next one's going to be read. I don't know why this is not lining up. Okay. All right. Let's go ahead and. Okay, so I think this is just enum support for events from the built-in Linux epoll system. So this just allows us to sort of, in our own code, we can, without having to hand type out these numbers, we can just sort of go, is it currently reading, is it right, what is it doing, type of thing. That's my assumption. We'll see if I'm right. Pull out. Okay, you pull out. Whoa. All right, let's do. Trig. Oops. I don't know why I added that space. Let's see, we pull it. Okay, let me space these out a little bit for evenness. Alright. Semicolon. End that block. And then, okay. This is some interesting syntax. So let's see, we're going to do a const expression, which basically means the compiler may optionally be able to evaluate this at compile time, if I'm not mistaken. Let's see, I'm going to confirm on that. Alright, let me continue typing here. Okay, so yeah, let's see. The const expression indicates that the value of a variable or the return value of a function can be computed at at compile time. So in essence, this function or this so apparently this can actually be so I'll show you what I'm looking at here. So I'm just copying this stuff right here. So the return of this can be evaluated. The return type of operator, if I'm not mistaken, can be evaluated at compile time. So it can basically evaluate this portion at compile time. So we'll see how that works out in general. Let's see here. No except term static cast. Give me 1 sec. Just looking something up here. Yeah, okay. Oh, okay, okay. Alright, so sorry. I'm trying to make sure I'm clear on what I'm writing here so that I'm not clueless as to what the code is trying to do or indicate. Okay, let's see here. Let's go down. We're gonna learn all sorts of stuff today. So, what is a static cast keyword? I actually don't know. I have some guesses, but I don't know for sure. Okay, so this is apparently like a compile time cast. It can do implicit conversions between types such as integer to float or pointer to void pointer. Okay. Alright, so this is again some kind of compile time casting. And what are we casting? Well, it looks like we're casting to an int, uint, unsigned int 32. And what are we casting to that? We're going to be casting okay, so we're basically casting A and B, which are passed into an unsigned int 32. And then we're doing a bitwise operator. In essence, to combine combine like the enumerator flags together. So that way, I think what the goal is here is you can have, if I'm not mistaken, I think you can basically even though this is supposedly returning just one enumerator of event type value, I think it's allowing you to combine flags using the bitwise operator here. I think what it's going to do is it's going to allow you to sort of pass in two event type values, combine them. However, I don't know what the final result will be. I think what it'll do is combine both to sort of represent a new sort of enum value, but I could be totally wrong in that, so I'll double check myself on that in a second here. Alright, so now we're casting B to an unsigned int. This syntax is a little different from what I'm used to. I'm surprised this doesn't. Okay, never mind. This is actually right. Okay, alright. Moving on. Let's see. Cool beans. Alright, the next one. Give me one sec, guys. I'm looking something up here. Just double checking my stream. Looks good. Cool. Okay, I gotta go block people that are chatting. How do I do that is the question. Dang it. Yeah, I don't know how to, oh, here we go. Click on their name. No, I do not want to buy viewers, thank you. Alright, that's cool. Very odd. Can't see my stream on this other platform. Okay. Alrighty, guys. I apologize. Let me get back to, let me check something. Okay, let's go ahead and just start typing out our next method. Const expression. Event type is what's going to return. Let's see, the function name is operator. Except this time it's an ampersand. Okay, so this one is going to take event type A, event type B. Oops, no except. I guess that means no exception. It's really windy outside today. It's like making a lot of racket. Okay, so we're going to static cast event to event type. I'm just reading something here just to kind of get a better understanding of how this bitwise operator is working in practice. Okay, let's see here. Okay, so I think what this is doing is just enabling us to use the event types in comparisons, I think. Because it's actually not making a lot of sense to me, just from the high level. I'm not sure actually. Let's see here. So if we use the bitwise operator, so I think this is kind of C++ compile time type magic where in essence it'll allow us to combine event types, enum type values. Let's see here. What does it say about the overload Z enable event type likely in enum to be used as a bit mask flags type. yeah, I mean, it's an enum. So the operator, the OR operator here, basically lets us combine flags. And then apparently the AND operator lets us test flags. I assume test as in make comparisons. Let's see, C++ enums don't natively support bitwise operations that return the same enum type. Let's see here. That return the same enum type without these overloads. Okay, back to coding here, because this is, I'm slowing down. Okay. Alright, so we got this guy, let's see, we're returning static, static cast, and this is wrong actually up here. I just realized this is missing an underscore. That's actually a keyword. Alright, let's go back here, let's go in static cast. Make sure I'm reading this code correctly. So unsigned int 32. Again, this can be evaluated apparently at compile time. Potentially. Doesn't mean it always will be, but it can be. Okay, so now we're doing an ampersand. So static casting the A event type to unsigned int 32, and then static casting the B to a 32, and then apparently this ampersand here is going to do a test, I guess, to see if they're, I guess, if they're equal to each other. Not sure what's going on here. Let's see. Cool. Okay, so I guess this just allows us to do comparisons on the event type flags. That's kind of what these are. It's kind of boilerplate. execute, read, write. Alright, back at it. Let's see here. So we've got our operators for the enum comparisons. I'm gonna double check these keywords here. Let's see. Yeah, that's correct. Correct. Okay, cool. That's good. And then we're going to do another method that whose return type can potentially be evaluated at compile time using const expression. I'm sorry, this is muscle memory. Okay, so I should say return value. I think the return value can actually be evaluated at compile time. Okay, so const expr bool, so it returns a boolean, has event type, events, let's see here, event type flag, no except, alrighty. Heavy typing. Okay, let's see here. So we're going to return static cast event 32 unsigned int. Okay, I'm actually going to remove that so I can focus on okay, so let's see, static cast events and the flag. And if that results in a non-zero value, then that means it has an event. Excuse me, that means it has this event, the flag, I believe. I believe that's the goal here. And so that would probably be using our boilerplate here, this operator, and it's going to take the two and compare them. Why this is events plurals, the part that's a little beyond me. I assume what they're doing is combining events. And so it may be maybe multiple events, but it's not like an array. And what they may be doing is combining them using the bitwise or method to basically combine flags, then to pass those multiple flags into here, and then basically do the comparison to this. to this flag that's being passed in here. And if it's non-zero, looking at our code up here, it's going to cast them to integers. And then it's going to do a bitwise operation. Compare them to each other. And if they, so I guess if one exists in the other, the and comparison is actually going to match any maybe go look at my example I had earlier. So they must both have basically, sorry, in this example here, so they basically must have matching in the unsigned ints, I guess. They basically have to have matching, both sides have to have the matching bits. In order to know that the event passed as the flag, the event type, I should say, the event type passed as in this flag variable, basically saying that it does indeed exist inside of, it does match one of these sections. So, alright, let's go ahead, moving on. Okay. All right, continue. Let's see here. I was trying to get away from you. And you just showed up. I tried to block you from all my chats, but I just can't get rid of you. Oh my goodness. This whole time my mic has been like a mile away from my face. Yeah. My bad. Anyway, I'm glad because I don't want anybody to listen to my ramblings trying to refresh my memory on bitwise operators. It's really embarrassing. All right. Let's see here. Callback. Structs. Alright, FD is probably file descriptor. And then file event type, events. Alright, so event callback. Using event callback, let me have AI explain this to me. Alright, sounds good. Alright, this line defines a type alias using the using declaration, which is modern C++ preferred over type def. Okay, so it's kind of like a type definition. Alright, so let's see. Creates a new type alias named event callback. Okay, so it's being aliased to a function of type void with parameters, file descriptor, and event type. Events. Okay. The template parameter describes the function signature. Yep, got that. Okay. Simple enough. Unfortunately, in other languages, the using keyword is kind of like a wrapper around, usage of some class or entity that basically depends on that basically occupies a resource. So like if you're making a database connection or if you're connecting to a file, you can use the using keyword in some languages to basically say that like using some file handle class, and then once it exits the block, by the way, the syntax is probably wrong, but hopefully this gets the idea across. But let's see, then you can say, you know, read line 5, you know, the text equals, and then you can read that line. Once it exits out of the block, it'll automatically close the buffer or the handle, basically the clean up the resources occupying access to the underlying file. And the reason that's why the whole using thing kind of threw me off here. All right, back to it. We got a method. Now let's create a struct for FD registration. Okay, coroutine. Sorry, it's a little bit of a weird one. Snake case. That's called handle. That is a coroutine handle. Event callback. Okay, so we're referencing our type. Yeah, we're referencing our type up here. Now this is probably not even doing syntax highlighting. I wonder if I can fix this project. This sucks. Let me try to do. Let me try and configure this project so it understands this is a C++ project. It might not. I don't know if okay, there's no SDK that I'm aware of. Probably need to do a module, and I'll make the Well, that sucks. Let's see if they have something for C++. New executable. No, it's not what I want. Oh wait, what was this? Who provides this here? Full line code completion, design to supercharge your code complete. I don't even know where I got this from, or if I installed this, or this came built into IntelliJ. Okay, I guess there's not much. Yeah, I guess there's nothing really for, let me think here. Alright. I'll be right back. Okay, sorry about that. Alrighty. Well, that sucks. I guess I just don't get C++ support in IntelliJ IDEA Ultimate. I have to use C line. I kind of figured that, but I just wanted to see if I could get some support. Alright, moving on. Alright, so we've got a struct type, FD registration. Hi, Andy. Dog. I just realized there's like a major shadow on my face. I'm gonna move my light here. There we go. Alright. So we got a struct here, we got FD registration, file descriptor registration. We're going to do a struct for wrong place. Okay, struct timer entry. Another struct. It's going to be using the chrono built-in system, I guess C++ types. We're going to do steady clock. Interesting name, as opposed to a shaky clock. Okay, standard coroutine. Let's see here. Okay, so the coroutine handle and it's going to have a method called operator that returns type boolean. I guess it can't be evaluated at compiler time, so it's going to just be a standard function. Wait, am I reading this right? Yeah, function, okay. I didn't know you could have functions on structs. I don't know if that's new or not. Maybe I'm crazy. Maybe I'm just making stuff up now. Let's see here. Okay, so by ref other const no exception. I actually don't know what const no expression means. Value cannot be modified. Yeah, makes sense. I know what const means. When applied to methods, it means the method won't modify the object's state. Okay, so it won't. Okay. When used together, it typically appears in a method declaration to indicate that the method won't modify the object's state. It also won't throw any exceptions. Okay. Okay. Fair enough. I believe you. Alright, let's go back here. Let's put this... Alright, you know what I forgot to do? I forgot to share my stream. Sorry guys, one sec. Alright, let me throw this up here. Cool, it fit. Right on. Alright, we'll see how that works. See if anybody picks up on that post. Okie dokie. Alright, back to it. Let's see here. So, bool operator. Alright. Sorry, I keep getting sidetracked here. Let's see here. So, let's see. What is this? Bool operator greater than symbol. Overlaying syntax allows you to define the greater than comparison operator. Works for custom types classes. Here's a more detailed explanation. It's typically used as a member function or a standalone function to compare two objects. Returns a bool value true if the left operand's greater. Okay. It's got some examples here. Some values greater than some other value. So we got other passed in, and we're comparing, I assume, to this current class's some value, whatever that is. All right, let's apply that to this. Okay, so we're taking the deadline value. Is it greater than the other deadline value? Okay. Fair enough. Simple. Cool. All right, so moving on. All right, so now we're going to create a class called event loop. Or we're going to declare it, I guess. Okay. Defining the, I believe this is going to be the constructor. We're going to optionally take in a defined configured default max events. It's going to default to 256. That needs a semicolon. Take off my caps. Okay, so we got a loop. Okay, so this is going to be for the teardown. Alright, so we got event loop, take in, let's see, what is this? I actually don't. This is where I suck at C++. I haven't done it in so long I can't remember anything. Explicit appears to be a constructor declaration with the explicit keyword. The explicit keyword is a qualifier, a special qualifier that prevents implicit conversions and copy initializations. Okay. Prevents implicit conversions. And since it's explicit, you have to use the constructor. Okay. Okay, here's some examples. So no explicit, you can just define an event loop class and then assign it some number without no constructor call. When it's explicit, you can't just do event loop equals 42. You have to actually do event loop and then call loop method. Passing the number 42, or you can do event loop equals event loop passing 42. Okay. Okay, fair enough. And then how about this line right here? We've got what appears to be I think this is cleanup. Explicitly deletes the okay, so this explicitly deletes the copy constructor of a class. Okay. Oh, okay, this is the copy constructor signature. It expects an event loop and then the delete keyword, I assume. It takes a const reference to another event loop object. Normally, it would create a new object as a copy of the existing one, so we're saying delete. Okay, you can't use, basically we're saying you can't use that function. Okay. Okay. All right, let's just go ahead and copy paste the rest of these in. See what this one does here. Deleted, let's see, copy assignment operator declaration. Okay, so I guess you can't just assign it to another instance. But in this case, you're saying you can't, let's see. Let's look at the example for this one. Looks the same to me. Okay, Okay, so you can't, again, you can't assign, so you can't copy. Okay, so you can't move, you don't want it to move. How about this one? I notice it's got a double ampersand on the input param. Okay, so these two are for moving. This is for copying. Okay. Alrighty, so let's see what next. This is just the header file. I see why people loved C++ so much. Static. Let's see what this is trying to do here. This is my fire hose method of learning. Okay, so this is a static member function, belongs to the class rather than an instance. Yeah, that makes sense. Can be called without creating an object of the class. All right. Okay, so it's a singleton pattern. So this is, it gives you a reference to the current event loop instance. And it's a static method, so you can just kind of grab it from anywhere. Okay, cool. I like that. Surprisingly, AI is actually doing a half-decent job here, I think. Okay, so now we've got, we want to declare a run method, which doesn't return anything. Void run, boolean run once. It's going to take a, ooh, interesting. It's going to take a chrono milliseconds type param timeout, which I think will be defaulted to standard chrono milliseconds. Whoa. Stop method, which is going to not throw an exception. I always space on the no discard. The no discard attribute. Okay, let's see. Okay, it has to do with the return value, I believe. Let's see. Okay, so we're basically indicating to the compiler that the return value should not be ignored or unused. Let's see, no discard bool is stopped, so this method is going to indicate if the current event loop is stopped. Okay, so it's gonna register FD gets a integer with a file descriptor, some events, and then it's going to get a coroutine handle, which I don't actually understand what the open close brackets are for at the end of it. Okay, so coroutine handle is a low-level handle type. It represents a non-owning reference to a coroutine. Okay, fair enough. Okay, so the brackets represent the default template param. Now we're not inside of a template that I'm aware of, so maybe that will be declared when we make the class, the actual implementation of this class. You can also specify a promise type. Should generally not be used directly in application code. That's great. It can cause memory leaks. Let's see here. Struct task. Sorry, I'm just going through some examples here, trying to wrap my head around it. Yeah, okay. Okay, so apparently the handle, apparently this means, let's go back to our description. Apparently the open close bracket indicates a default template parameter. The default template parameter. Okay, we'll see what that ends up being in some of the usages of it. All right. Register FD. Event type. It's looking very similar. However, it has a slightly different signature, so I guess it's an overload. Event callback. Oh, what did I do? Let's see, modify file descriptor. Take in the events, the event enums values, enum values, I should say. Let's see here, it's void or okay, not void, sorry. So return nothing, unregister fd file descriptor, and that will take in, I assume, an int, and that's it. Simple. Okay. I like simple things. Okay, so now we want another no discard. So that's basically just an FYI to the compiler that, hey, don't ignore the return value of this. If you are, then that's something's probably not right. Get triggered events for the file descriptor. That's basically I think that's the Linux file descriptor int value. All right, let's see here. Okay, next we're gonna do alright, schedule. So the schedule method is going to accept a routine, coroutine handle of the current template type. So you get a handle. There's also a schedule after. That's interesting. Okay. Again. Okay, not again. That's going to take in a type of chrono milliseconds. A delay. Coroutine handle of the current template type. Then there's milliseconds delay and then a handle to some coroutine. So I guess that's for scheduling to start something up later, like on a timer or something. All right. Again, we don't want to ignore this return value. And this method is going to check has pending work. Const no exception. Okay. So we're going to have an epoll file descriptor method. Which I actually don't know. I guess it's going to return this epoll fd variable with a trailing underscore. I can only assume this is coming from. This is kind of where I get tripped up with C++. So I'm declaring basically a header file for the event loop class. However, I'm actually declaring a function, and then I'm actually including a return statement with this variable, which I don't even see declared anywhere. So maybe that'll come up later here. It just seems odd to me that you would actually return something in a header maybe it's some system variable that's just globally available. Let's see. Hang on. What was that? All right. So let's see here. Max events, const, no exception. Okay, so it seems like these are existing somewhere. Let's just do a quick, let's see, let's have AI break this down for me. Let's see here. Oh, whoops. All right, try that again. My bad. Good thing I checked that because apparently I mistypoed. I added a double const. Okay. Yes, returns an int type. It's called epoll file descriptor, or FD. So it's a const member function, meaning it won't modify the object state. I'm actually going to clarify that. What object state will epoll FD not modify? Okay, no exception specifies that this function won't throw away any exceptions. That's odd. Seems counterintuitive. To me, no except means it would not throw an exception, or I don't understand that. Modify, let's see, mark getter methods as const. I'm going to shrink this over so I can see the text. Okay, no except when you know the function won't throw an exception. Okay, so you could change, you could actually say get underscore epoll FD. Got it. Okay, so basically declaring const is saying it will not modify any state of this current event loop class. Okay, fair enough. The only part I'm not clear on is where is epoll fd underscore from? That part I'm not clear on. Let's see here. Okay, we don't have a private section declared yet in the class. This is probably referencing some private variable. Okay. Yeah, it's not declared anywhere in here. I already searched for it. Okay. Let's continue on. All right, so cool beans. Let's move on to the next step here. Okay. Oh, okay, I got ahead of myself. Now we're going to declare those variables. Okay. Now it makes sense where they're coming from. We got an int epoll fd, int max events, and then we got a boolean stopped underscore. These are the private variables of this class, and then we're going to declare a bunch of private variables, a vector, let's see, of epoll event, okay, so we got events buffer, so that's going to be a vector of epoll event types, which is not declared yet. Let's just review this really quick. Just make sure I'm clear on the syntax. Again, disclaimer, I have not coded in C++ in about 16 years, so I'm pretty much relearning it nearly from scratch. Okay, I'm aware of what a vector does. Okay, so it's a struct epoll event. System structure used in Linux is epoll facility. Okay, so it's maybe some kind of system type. Typically contains struct epoll event, and then contains events and some data. Okay. Yeah, I don't care. That's the name of my variable. Okay, moving on. Unordered map. Int, which I think is the file descriptor, like identification. And then we're going to have our custom FD registration type. registrations underscore. Again, these are all private, so they're only internally accessible to the class. All right, so now we're going to have a queue. The queue I'm not familiar with, standard queue type. Let's take a look at that real quick. So this is a container adapter from the C++ standard template library. Provides a first in, first out data structure. Elements are inserted at the back, so they're pushed. And then they're removed from the front via pop. Okay, makes sense. So that explains the first in, first out. So you add two items, you add one, then you add one. I don't know if you can oh, my camera's frozen. One sec. Okay, back to it. Alright, check. Looks like my audio's good. Oh my goodness, that freaked me out. Sorry, saw some kind of meme in a different chat. Okay, okay, sorry, I was just explaining first in, first out, which I think is kind of self-explanatory, but you got an array with, like, let's say, you know, 2 elements or 4 elements. Let's do this differently. I'm trying to figure out how to best to describe this. Put one item in, actually this hand. Here's one item, one hand, add another hand to the back, then basically first in, first out. So this is first in, this is pushed into the back, then you take this item, this hand out, and you basically process that in the queue. So let's see here. Implemented as a wrapper around other containers, typically DQ by default. Okay. All right, let's move on because I think this is hang on, I want to see if there's something unique about it that's different from like a vector or okay, it has no iterators, no random access, cannot be traversed. Okay, so maybe it's just more thread say unsafe. Ooh, okay, that's actually very interesting. Needs external synchronization for concurrent access. Wow. Okay, that clarifies a lot for me. Let's go back and let's do queue standard. What is it a queue of? So it's a queue of routine handles. Okay. Okay, priority queue. vector of type timer entry. Let's just see if we got, did I define a timer entry type? Yes, I did. So it's basically got a deadline and then a handle to a coroutine. So we've got a timer entry, and then we've got an array of timer entries for this priority queue. Okay, let me try to read this over here. Priority queue. Yeah, let's take a closer look at this. Make sure we understand what we're dealing with here. Provides a constant time lookup of the largest by default element at the expense of logarithmic insertion and extraction. Let's see, it's a container adapter that wraps around a container, usually a vector. Usually, by default, it's a max heap, largest element on top. Elements are automatically sorted when inserted. Okay, that's interesting. But how does it determine what is largest? I guess we'll find out. Let's see. Top is O1. Popping it is O log n. Push is O log n. Okay. Common use cases: implementing heap sort, task scheduling by priority, Dijkstra's shortest path algorithm, maintaining a top K list. Okay, so here's an example of inserting some elements. And then it's going to go, basically it's, oh, okay, so when you call top, it's going to get the largest value first, next largest one, and so on and so forth until you get down to 1. Okay. Okay, so it looks like it's going to be using this custom operator, comparing the deadline to order. So I assume that when that's what this yeah, so the comparator is the third param, I think, if I'm reading this right. Okay, got it. Okay. Cool. A lot of interesting stuff here with the coroutine, custom coroutines. Okay, if I can type void process ready queue. Process timers. Int calculate timeout. That'll accept chrono type milliseconds. Max timeout. Typo. Alright, calculate timeout takes in a max timeout. Yeah, I don't understand what that method's for, but we'll find out, I guess. Okay, so private needs to be have a closing. Needs to be part of this class, okay. Alright, close that off. So now we have a complete class. I do find this indentation odd. Part of me wants to indent in the private and public portions like this. But I don't know if that's standard indentation for most people in C++. Okay. Okay, so this actually, I missed something, I think, toward the beginning. I did. Alright, so let's take all this. Let's put all of this into a namespace. Wrong button. Okay. All right, so epoll FD is going to be the epoll instance file descriptor. Max events, configurable batch size, whether to stop or break out of the loop. Okay, that'll stop the run loop, which I don't think we've implemented yet. I think we only declared the run method right here. Cool. All right, so basically it looks like okay, so we're actually doing a min heap. So we're basically saying not do the oldest or largest deadline, but we're actually doing the earliest deadline on top via this operator on right here. So if the current instance's deadline is greater than the one passed in. So if the current instance is greater, it's actually going to get moved down. At least that's in theory what it should do. It should get moved towards the back, so that you end up with the shortest deadline in front. Okay. Alright, cool. Moving on. Alright, so now we're going to do the actual implementation here. Alright, let's include Coro event loop header. I am making mistakes here because I'm a noob. Alright, Coro event loop H, referencing the header file. And then some of these built-in C++ headers or includes. Let's do system error. Alright, so we're going to continue with the same namespace for consistency. Alright, event loop is the return type. It will be a pointer to the current loop. I guess it defaults to null pointer. So it starts out empty. Alright, so I guess I'll just review this really quick. So UNISTD is going to give us the close method for the epoll file descriptor cleanup. Standard accept. This, I guess, gives us the ability for logical errors. And then system error is basically for system call failures. Managing, I guess that's for the system error types. Okay. Sorry about that. I'm just reading something here. All right, so event loop, event loop. What the hell does that mean? All right. Alright, the part I don't follow is why the syntax is event loop, double colon, event loop. That's the part I don't quite follow. Oh, hang on. Is this the... Maybe I need to give it some more context. Hang on, I'm reading the code here. This might be the constructor. I'm suspecting this is the constructor syntax. Alright, let's just continue on. Okay, let's see. The syntax indicates constructor definition for the event loop class. Okay. Okay, so it is the constructor. Okay, so we're defining the constructor. Got it. Again, I have not used C++ in a long time, so I am extremely rusty. Okay, epoll. Create one. Whoa, I meant to turn on caps. What is going on with my caps button? Okay, what is this line? That was great. Let's see here. I don't know if they'll let me try C-line. That would be cool if I could. Because I remember I had already used the trial. So it probably is expired. I probably am not allowed to use it anymore. What in the hell happened to my text here? Hang on. There we go. That's my... Okay, that's why it was all whacked. Okay. Let's see what this does. I'm actually updating C-line. I might try it out here. Could actually help. Still downloading and installing. Okay. So. All right, let's okay, it says it installed. Let's see what happens if I open it. Should I import my settings? think I'm going to skip that for now. Okay, looks like they're letting me start another free trial. That's cool. Oh, this is very cool. I'm really excited about this. Let's go ahead and I'm going to close this. Actually, let me review this really quick. epoll file descriptor is so this is a Linux system call. So the create one epoll create one method. It creates a new epoll instance. It's an I/O event notification facility used for efficient handling of multiple file descriptors. So epoll clo exec is a flag passed to epoll create one that sets the close on execute flag on the new file descriptor. This means that if the program executes a new program using exec, oh, thank you, honey. Using exec, I apologize, my train of thought's gone. Okay, sets the close on exec. Okay, so file descriptor, close on execute, close on exec flag gets passed. So that means that the program executes a new program using exec CVE or similar, this file descriptor will be automatically closed. It's good security practice to prevent file descriptor leaks across program execution boundaries. Interesting. Okay. The function returns a new file descriptor, a positive integer that refers to the new epoll instance. This file descriptor can be used with epoll CTL and epoll wait to monitor and wait for I/O events. Got it. So we're creating an epoll instance. We're passing a flag to say close upon execution of the what is it, file, the actual underlying file. Let's see, this means it's execution program. It's a Linux system call. It creates a new epoll instance. So it's handling file descriptors. Okay, so the file descriptor will, the underlying file descriptor will be closed. Got it. Okay, now I'm going to stuff my face while I do this. Actually, give me 1 minute. I'll be right back. All right, my bad. Grab my glasses. Okay. Man, this bowl is full. All right, so I'm going to try opening this project in C-line. I don't really know if I want to use what build system I want to use. I mean, I guess I'll just use CMake. Detected Ninja compiler. Oh, C compiler, C, and then C. Okay. Okay, we'll go with that. I'm sure I'll pay for it later. All right. Let's switch IDs so we kind of have an idea of what we're doing here. Let me close. Let's see. I'm just going to read through this one more time carefully because this is just kind of losing me. Okay, so it's initialization of the epoll fd member variable. Okay. I assume this is like kind of like some shorthand syntax to initialize member variables. All right, let's use C-line. This will be a lot, I think, cleaner. Oh wow, it recognizes a C++ file. Okay, no project target. I guess I need to configure it. Let's see here. Excuse me while I blow my nose. Okay. C standard C17. I don't even know what version that is in the C world. C++ 20. That's good. I want C20 so I can have the C routines. Excuse me. Coroutines. All right. Let's create a CMake list. Okay, we can always update it later. But for now, it's just going to include these folders. Not sure what this is. Looks like, yeah, it's kind of weird. Okay. Excuse me. Hit some spice. Cool. So we're already getting a bunch of exceptions and errors. Now I can't talk. That's great. Okay. Clang tidy, redundant, event loop, declaration. Huh? What? I don't see the problem. Okay, let me type this all out and then I'm going to look into that here in a second. All right, max events. Stopped. Default to false. Events buffer. Okay, I guess it doesn't like tab. Buddy, events buddy. Okay. Alright, so that will init all of these variables, I guess, which is kind of odd. And then what we need is a open close brackets. What is this complaining about now? Expected? Am I missing, what does it say? Expected open? That's right here. Oh, you know what? It's probably because there's no content in here. Hang on. Let's do epoll fd underscore. Nope. If it's less than 0. Oh, cool. It's just giving me, like, it's just giving me all the suggestions. That's kind of cool. Okay. Throw std system error. Let me just type out what AI is kind of spitting out here and see if it gets any, you know, compile errors along the way. Error num standard system category. Epoll create one failed. Alright, change. What is this saying? Use of undeclared identifier. Did you mean epoll fd without the trailing underscore? No, I don't think I did. All right. Does not name a non-static data member or base class. Yeah, this is declared, but it's declared as a private variable. Oh, okay. Might be simple. Oh, we got errors in here too. I might have to fix all these. Hang on. No, Andy. No, it's my food. No, I'm not sharing it with you. No. I'm not sharing it with you, buddy. Okay. Let's go ahead and add that. Next error. Coroutine handle. What? No. Is that supposed to be handler or handle? Hang on, I'm just going back through all the code I was copying. It's supposed to be coroutine handle. Can't resolve symbol, coroutine handle. Why not? Change all coroutine handle. No, there's something, I wonder if there's somehow it's using the wrong version for this. CXX standard. I think this is actually supposed to be, I think the problem is I've got C++ 14. It should be 2020, I think. Oh, I don't have the plugin. Hang on. All right, move. I'm busy, Andy. I'm busy. Yeah, I'm busy. You gotta let me focus. He's mad because I'm not eating my food. Okay, my suspicions were correct. We need C++ version declared as 20 in the make list file. Okay. Hey, let's see what that did to the header file. Come on, update. Okay. That might have did something. Let's see. No template named coroutine handle. Okay, this probably should be... Yeah, that's something's missing there. Let's see, FD registration. Did I just completely forget to type this? Oh, gotta close all these off. Bad habits from JavaScript. Or good habits, depending on who you ask. Okay. Get out of here. No. Move it. Out of here. Come on. Get out. That's enough. Man, this dog does not give up. Okay. I'm gonna need a freaking spoon. Y no podía respirar. Okay, I promise I'll get back to coding in a second. There are so many errors. Okay. Okay, we're in event loop. The header. Give me a minute, guys. I gotta fix a bunch of stuff here. What did I do wrong here in the syntax? Register FD. Really? Just a semicolon? Okay, something's wrong here. Equal FD. Okay. Oh, it's a function. Okay, keep moving on. So this schedule after function is not implemented? Okay, I'm aware of that. I'm currently in the process of trying to implement it. Okay. Let's see. So apparently I need to adjust my make export compile commands. Sorry, CMake export compile commands. Okay. Let me close CLine and open it again. Okay, I'm seeing less errors. A lot less errors. That's good. Okay, we're done with food. I'm gonna let my dog lick the bowl. Hello. You want it? Okay, I apologize for the 50 millionth time. I should probably just remove this video and edit it down. Condense it or something. Alright. So. Okay, there we go. We're back. Okay, so if there's no valid, I guess, file descriptor, that means it failed, throw an exception. I don't know what this system category is. I assume that's literally what it is, saying that this error is of type system, which is a category. Alright, so let's do current loop. If the current loop is not null pointer, which meaning it's set to something or it's been updated or changed, we'll do a runtime error. Event loop already, let's change the wording. Okay, so this just kind of keeps us, since it's a singleton, except for, I mean, I guess there will be an instance per thread. So basically this just says if it's been set, this thread already has a basically already has a loop that's been defined for this current thread. Okay, current loop is going to equal this. So otherwise we create, if everything looks good, we just create a, we just assign the current instance to the instance variable. And oh, okay, I see. So up here it's thread local. I think that's probably exactly what it means. It means the variable is in essence, it's scoped to the current thread. Let's see, keyword storage duration specifier tells the compiler that a variable should have thread storage duration. Every thread in your program gets its own independent instance of that variable. Perfect. So it is actually scoped to the current thread. And each thread has its own version. Okay, moving on. So let's do basically the resource cleanup. So when this class needs to get torn down, maybe stopping the process, for example, ending it or something. Okay, so if there's a file descriptor, call close, which I assume comes from it's got to come from one of these. It comes from UNI STD, UNI standard, which I don't know what UNI stands for. Okay, now let's go to current loop is if it's currently equal to this. Okay, so if the current class being torn down, okay, so if the instance that this gets called on is equal to the, which I don't know if you even need that protection, because it would be getting called on its own instance anyways, I believe, during teardown. But I suppose it could call teardown, like it could remove this class instance, but it could be for a different current loop. I don't know how that's possible. Okay. There we go. Worded a little better. Okay. All right, it's good defensive programming. All right, so it's a good check anyways. Okay, event loop by ref. So it's going to return the current instance. For current, make sure it is truly the current wait a second. Okay, if it's null, I mean there's no event loop already on this thread. Otherwise, return the current pointer to the loop, the current loop. Okay, so we return a pointer to that loop. Okay. All right. Okay, we mark it as not stopped, so that means it started. If it's not currently stopped, kind of an odd check because we just set it to false. Oh, okay, that's because it can stop during the loop. Has pending work. That was weird. Alright, run once. I have no idea what I just did. Let's try that again, guys. Run once. AI is like trying to take over. Okay. Okay, I don't know what run once is, but I have a feeling we're going to define that here. So for our event loop class, we're going to define run once. It's going to be of type chrono milliseconds, passing in the timeout. Process ready queue. Excuse me. Okay. I'm going to return false. If the current instance's stopped variable is true, return false, exit out. Let's see here. Okay, so we're calling calculate timeout. I don't know why this is all gray. I don't know what method. Is this something in the header? Okay, so I guess we're going to define that later. This should be wait ms. So wait, get the timeout, and it's going to be the result of calling epoll wait. So we're going to get the pass it the file descriptor. Okay, AI is doing way too much. It's kind of throwing me off. What are we doing here? Okay. Events buffer, get the data from it. Nope, I don't want to do events buffer again. I want to do max events plus the wait ms. Okay. If n is less than 0, I don't know what this means. I don't know what e int r means. Let's see here. In C and C++, that expression is a standard way to check if a system call is interrupted by a signal before it could complete. Okay, so arno is a global thread local integer variable. Okay. Interrupted system call. Okay. So if the current global for the thread, global error number, is equal to interrupted system call, go ahead and just return has pending work result. Otherwise, throw an exception. Okay, I'm just going to skip all that syntax. It's just a basic for loop based on in milliseconds. No, excuse me. The result of in, which came from epoll wait. So it's 0 or greater. We're going to try to iterate over it. Over the however many times that value specified for. Okay, so we're going to get the data from the current events buffer. We're actually getting the file descriptor. I'm sorry, the data file descriptor, and then okay, static cast to event type. And we're going to try to let's see here. I want to get a better handle on this syntax. Converting low-level Linux kernel event flags into your high-level C++ abstraction. It accesses a specific element in an array of struct epoll event. Okay, so I guess that's the buffer, position I. It's getting an epoll event. Okay, events is a bit mask, which contains flags representing what happened on a file descriptor. And then we're going to cast that to a matching event type. We're taking the raw bit mask, telling C++ to treat it as an instance of your custom event type. Okay. Okay, so I'm going to do IT registrations. Dot find the current file descriptor, and this is typoed up here, I think. Cool. What is registrations, just for a refresher? Okay, file descriptor registrations by integer, which the int is the file descriptor value. Got it. And it is of type unordered map, so the find method is going to search it. Okay, if it's not the end of the map, which I assume means that it searched and it didn't find anything. So if it did not find anything, second dot triggered events equals triggered. Whoop. Okay, second gets the FD registration struct. Oh, okay, so that's saying for the current map iterator, get the second portion, get the value. Okay. And then the value is our FD registration. Then it's going to assign the current event type, casted event type, to the triggered events. Okay, so we're going to update the event on that registered FD registration. Okay. Okay, if it has a handle, get this out of the way, it's distracting. Ready queue. Alright, so we're going to add the values handle to the queue, which ready queue is not available for some reason. Maybe because we haven't defined it yet, or yeah, I'm not seeing the ready queue in here. Let me go scroll up my code example, see if I can spot that. Okay, there should be a ready queue defined as a private variable. And it's another typo. Okay, there we go. No viable operator equals matches arguments of type event callback. Now what am I missing? Let's see. Event callback. I actually don't know what's causing that. Alright, finding a bunch of errors. Triggered events should be type, event type. Whoops. Okay, cool. That worked. Okay, so else if triggered What are you doing, doggy? What are you doing here? Hello. Alright. Oh. I have to type though. I can't pet you and type at the same time. Okay. That's a total typo. Okay, so if there is a callback, then we want to trigger the callback. Got it. Second dot callback. Okay, outside of the loop, we want to return has pending work. Which is not defined yet. Yeah, I think that's all for this portion. I got the run once method done. So we have run. If there's pending work, call run once. Not sure where the timeout's coming from. Alright, so we need to implement the stop function. I'll just go with that. Stopped equals true. Oh, whoops. Okay, register FD. Okay, this line of code is a concise way of combining event flags for a Linux e-poll mechanism. Expression, events, or edge trig takes an existing set of flags of events, existing set of events like read write, and adds the edge trig flag to it. Okay, so it's adding this. Okay. Okay, so it ensures that epoll et is enabled for this file descriptor, regardless of what other events were requested. Why it's used in high performance networking, edge triggered mode is often preferred because it only notifies the application when the state of a file descriptor changes, which can be more efficient than being constantly notified as long as data is available. Notified as long as data is available, level dash triggered. Let's see here. Okay. Okay, ev.data.file descriptor equals the current file descriptor being passed. EV is an epoll event, so we're just building this current event, probably for the system call. It's probably what it expects. Whoa, okay. Pass the file descriptor passed in. I don't know what the file descriptor. Let's take a look at this, see what this is doing. That calls the, I hate how this thing scrolls. It's so annoying. Let's see, that line of code is a call to the Linux epoll-ctl system call. It is the core mechanism used to tell the operating system which file descriptors, like sockets or pipes, you want to monitor for activity. In the context of your event loop, here's a breakdown. So epoll fd underscore is the file descriptor for the epoll instance itself. You created this earlier in the constructor using epoll create1. Think of it as the manager or container that holds the list of all the connections you're watching. Okay. Epoll ctl add, this is the operation flag. It tells the kernel I want to add a new file descriptor to the interest list of epoll instance. And then you can modify for an existing file descriptor being watched, or stop watching it. FD is the target file descriptor you want to monitor. Okay, got it. This is a pointer to a struct epoll event. It contains two vital pieces of information: the events, okay, which events you care about listening to, with the edge triggered mode, okay, and then the user data. Okay, if it returns 0, that means it was successful. Alright, so if it's less than 0, calling epoll ctl, if it's less than 0, that means it failed. So we'll throw an exception. System error num, which is a global error number for the current thread. Of system category, and then I might want to update this message. So epoll ctl add failed. Cool. Okay, registrations. That's wrong. Actually, that might work, but I want to do a new FD registration, FD events, null pointer, and then we're going to move the callback, which apparently is not declared, I think. Pass event type, none. because there is no event happening at this point. Oh, you know what I got wrong? Let me close this. I can't even see what I'm looking at anymore. Okay. I don't know where it's getting called. Oh, whoops. Okay, that was my mistake. FD registrations, registration. Kind of is expecting a, oh, okay, hang on. I need to put the handle here. Okay, there you go. So we've got FD, events, handle, null pointer, and then event type none. And we need to close this off. All right, next method. So we're doing another register FD with a different signature. Excuse me. Event type, events, event callback, okay, struct epoll event ev, ev.events equals static cast uint 32t I just now saw you guys typing in the chat. Epoll. It's called epoll, man. Linux systems. Excuse me. Linux is like IO kind of callback mechanism for event handling. Okay, that's not the description I got earlier, but it's basically Linux kernel like support for file descriptor like event listening. It's actually really good for using like coroutines in C++, so you can have like basically asynchronous operations. So events equals static cast uint 32t combined with edge trig ev.data.fd equals fd. We're going to call the system Linux system method epoll ctl with a file descriptor. Oh, okay. Apparently it's just going to type it out for me. Let me just confirm. Epoll add, passing it the current file descriptor, and then a reference to the current epoll event. Okay, that's good. If it's less than 0, it means it failed. So we throw an exception. Registrations. This is a different signature. We want to do fd events null pointer. We want to move the callback. Move callback. Event type. Oh wait, no. I want to do modify FD. Alright, let's just make sure this is correct. Epoll control. mod. Okay, that looks good. Okay, and then locate the registered file descriptor. Then go to the get that iterator. Go to the second, which is the value of the map. Set the events. Okay, so it's just keeping these in sync. So it's updating our custom FD registration events and the system events. Got it. Unregistered FD. Okay, so it's basically just use the CTL delete and then remove it from the map. Okay, apparently I don't need to specify struct here. You love the sound of clacky keyboard, huh? Yeah, it is a clacky keyboard. I need a new one. Alright, let's see. Okay, we gotta add some more methods. This is gonna return event type. Okay, get triggered events for the current file descriptor. What is wrong with this? Let's see. No return statement in a function returning non-void. Oh, that's fine. I'll type that out in a second here. Okay. Okay, so find the registration, the FD registration by the file descriptor. If it is found, so if it's not equal to the end, return the value triggered events. Else, otherwise just return none. I would think this should error if it doesn't locate the file descriptor in the map. I don't know why you would just default that to none. Seems odd. Okay, so if the handle is true or exists and it's not done, push it to the ready queue. Okay, so I guess that just means it needs to be added to the queue for processing. To be ready queue for processing. Huh. Let's see here. Timer is push, deadline. Plus the handle. What is timers? Timers is a priority queue of timer entry Okay. I thought you had to specify the comparer.
But I guess we're not doing that. We're just doing... Oh, I'm sorry. So timers is basically a queue of this type, and you can just push timers to it. You can push of type timer entry. It will take care of the rest. However, if I go to timer entry type, it has its own operator, comparison operator on the type, which I guess it's inferred by the compiler that this is going to be of type timer entry. Okay, I guess I'll go with that for now. I don't really know if that's a good thing or a bad thing. I cannot seem to hit my exclamation mark today. Okay, ready queue. Return not ready queues. So ready queue is not empty. Timers is not empty. Registrations is not empty. So basically, if anything is not empty, we still have pending work. Okay. Process ready queue. Size T. Count equals ready. Ready queue. Dot size. That's not what I want to do. I actually want to do... Okay. Okay, take off the top of the heap. Okay, take off the front of the heap or the top of the heap. Remove remove it from the heap. If we have a handle and it's not done, resume it. Which is handle is of type coroutine handler. It'd be cool if Copilot would stop trying to type everything for me. Because it's making it where I can't type anymore. Okay. If the timers is not empty, okay, so we're processing timers. If timers is not empty, and timers and timers top of the queue deadline is less than or equal to now. So that means it's already passed. The deadline's passed. Then we need to... Got it. Okay, so we need to get the top of the heap handle, coroutine handle. We want to pop it from the timer's queue, the queue, priority queue. And then let's see here, the handle, if there's a handle and it's not done, okay, then resume. I'm so sick of this thing typing for me. Okay, that's actually needs to be const. Wait, what's wrong with this? Calculate timeout. Oh, no return statement. Okay. Alright, so All right. All right, so if timers is empty, if the ready queue is not empty, return 0. If timers is empty, get the max timeout count, cast it to an int, and return that. So return the max timeout. Okay. Then what? So if there's ready queue items, return 0 for the calculated timeout. If the timers is empty, there's no timers in the timer there's no queued timers, then we just return, in essence, I believe, the max timeout value. Excuse me. Next timer, oh, whoops. I'll read this code in a second. I'm just kind of typing it out. I'm actually copying it from this Claude Code example. Okay, what are we doing here? Chrono, duration, cast. That's interesting. Standard, chrono, milliseconds. It's very verbose. Next timer. Okay, so the delay is going to be next timer, which is the deadline minus now. What's the difference? If the max timeout count is less than 0, then return static cast int delay dot count. Okay, static And okay, this code's really funky. Let's see. Calculate the timeout. Down here we get the current time. We get the next timer on the top of the heap, on the top of the queue. I forget how it's ordered. I think it's orders the shortest, the timer with the closest deadline, the smallest deadline first. So it's going to get the next timer that's coming up. If it's less than now, that means that the time's already passed. So we don't, the timeout is basically 0. That's the shortest it can be. We've already passed it. I don't know why there's all this white space in here. Oh, okay, it's just the ID, I guess. Huh. Alright, anyway. I hate that. Okay. Otherwise, if the timer has not passed yet, what's the difference from it? How much further into the future is it? So how much longer till it comes? If the max timeout is less than 0, if the max timeout is less than 0, get delay.count. Okay, get the delay, cast it to an integer, and return it. Otherwise, use standard min to determine whether to use delay or max timeout, whichever one I guess is the minimum, whichever one's less, and then count that and cast it to an integer and return it. Okay, I'll have to write some, maybe write some tests around it using, I don't know, Google tests or something. Okay, let's see what it says here. The breakdown is, excuse me, I think I'm going to take a break here in a second. Okay, so process ready queue. So process ready queue only processes coroutines that were ready before we started. Avoids infinite loop if coroutine reschedules itself. It says it avoids infinite loop if coroutine reschedules itself. process timers. Let's see, so process timers is going to move expired timers to the ready queue. Okay, that's actually the simplest one. So basically this calculate timeout, if we look at the usages, gets called right here in the run once function. Given a timeout, it says here's my timeout. And then it uses some logic to determine the timeout based on the current queue's next upcoming timer, or timed queue item. I don't even know what to call it. However, if it's 0, that means run it now. So if we go back to the usage, it's basically going to pass wait ms of 0. If it's basically saying, if it thinks it determines based on the next upcoming queue item, queued timed queued item, if it comes back 0, that means go ahead and execute it now. Okay, I think that's enough for me today. I got set up, I got Sea Lion working. I basically got I got the event loop class kind of typed out. I really don't expect it to work on the first try. I think there's going to be a lot of iterations. But pretty soon I have to do... I need to create a task class next, and from there we'll we'll create the building blocks. I might stop and try and write some tests against it, or just some code that might just verify these queues, like make sure the loop doesn't get stuck in certain cases. So maybe give it some items, queue some items to tasks or things to process, or I might need to build my task class first to use it, or maybe I can just directly add to the queue and use the event loop and spin off a couple event loops for a couple threads, or maybe just one thread actually, but whatever, just spin off some event loop event loop instance, add some things to the queue, run it, maybe just log output just to see what it's doing internally, and then make sure it doesn't go insane and lock up my system, which would be fun. Cool. Thanks everybody. Catch you guys later.